Welcome to section I/O and Advanced Fundamentals. Here's what we'll learn in this section. We'll learn more about I/O and Advanced Fundamentals. In particular, basic stream I/O, vector and matrix operations in a little bit more detail, and then we'll have a big example problem, which is the perceptron part 1 and part 2. Okay, well, starting with basic stream I/O. In this video, we'll cover stream I/O and also formatted I/O using Printf, and also formatting using sprintf. We're not going to cover that in detail in this thing. We'll just tell you that it's for formatting strings. Instead of outputting to a file or outputting to a terminal, you can also format to a string and make formatted strings that way. And also, we'll deal with a few OS commands that are handy. Okay, formatted I/O using cfprint. Okay, opening, using and closing strings, we'll show that. Formatting output using printf. And here's a good example right here. Let's go right to the example. Here we have 8.3f, and the percent sign means that's a format. These are all in quotes here. And then we have 8d. 8d is decimal integers. 8.3f is floating point with 3 decimal places after this, and this is the width of it, including the decimal point and the 3 decimal places after. So here's what happens to these two numbers after we print them out. You'll see that this one gets rounded here at this point. And also it prints out this one as a decimal integer. In each case, you'll see that 8 positions are used up here. Okay, the width determines this width here. Width is also used another way. When you're using the G and little and uppercase G, they correspond to little and uppercase E. They do the same thing, except in the case of the little g and the upper G, they use width for the entire width of the number. And so you can go with higher precision than if you just use F for these guys. They'll go to whatever precision you give the width to be, assuming that the number has that precision. Okay, and these are used for hex out and unsigned integer and string. You want a string output using these. Okay, we're back in Julia, and we're going to put in this familiar well problem, but this time turned it into a function and condensed it a little bit. We're going to put in time. That's the time for the rock to drop down the well and for the sound to come back. And that'll give us the depth and the terminal velocity. So we have a rock and a stopwatch as our tools and in this little program. I'm also using printf because I'm going to use that later. So let's go. Okay, we got that in. Now let's go ahead and do some printing. Okay, but you see these are very long numbers. We don't want those long numbers. So we're going to trim them by taking the number, multiplying it by 10, then rounding that, and then dividing by 10. So let's do that. Okay, so now we got some numbers that look reasonable because we know our precision isn't good enough for those very long numbers. Now let's go ahead and print them here. And let's go ahead with this. Now we're using printf. Okay, so you could do the same thing with printf, and we put some more things in there as well. So let's see, we have the depth 107 meters, and we have this printf printed out the 5. If we wanted to make a table, this would be one of the entries in the table that gives us the time, the depth, and the velocity. Okay, this time we're going to take some well data. Well, actually, it's pseudo-well data. I was going to say that we went out and had a bunch of people go and measure a bunch of wells with a box of rocks and a stopwatch, but that's not really the case. But we have some data that pretends to be that, and it's called well-in data. So let's take a look at that. I'm going to click on that over here. And there it is. So here's the times that we got. And here's the name of the place. So let's pretend that's real data. And we're going to go and take this now and execute this. And I'll talk about it after we do it. Okay, it looks like it executed just fine. And what we did here, I use this one up here since it's color-coded for us. We opened a couple of files. We read in a line. Each time we read in a line, first of all, it's a true while loop, so it doesn't get out by itself. You have to break to get out. And I checked to see if we had an empty line. If you had an empty line, then it broke and got out of the loop. Then I split the line into pieces based on blank, which is the default. And then I parsed that, just the first element of that, to float 64. And then I ran it through the well problem, because that was the time. And I got my my well depth and my terminal velocity. And then we printed all this out. Well, we actually didn't print it out. We sent it out to WOut, but using the Printf formatted print routine. We said done and printed our file. So we see done here, and then we closed our files. So let's see what we got in the output file. And there's our output file. So this column is the time. This column is the depth of the well in meters. And this column is the velocity in meters per second. So, and these are the places that the data was taken. Of course, there was no data taken, but this is it. This is our phony data. Okay, now let's look at a couple of other things that we have here. I think we did this one before. This is a PWE. This tells you what your working directory is. So let's use that right now. And it tells us that it's in Julia 1-4 videos. And you can see it over here. The next thing we're going to do is look at, this lists the files in our working directory here. So it says read directory. And those are the files as you see up here. Okay, now we can do a stat on this. This is the data file. This tells us what the mode is. And the important part of this, well, this tells us the length of the file in bytes. And this is a code that gives us the permission codes. A mode 6 means that the owner can read and write. Mode 4 is read-only, and so this is for a group, and this is read-only for the everybody else. So this part of it is the code that says who can read it and who can write it, and who can execute it, but that's not of use here, because it's not an executable file. Okay, so supposing we want to change that, we can do that with change mod. And now we do a stat again. Well out CSV. And we see change that to 664, whereas I think before it was 644. Okay, so here's what we've learned: opening and closing files or streams, formatting output, formatting the format control characters, and a few OS commands.